Okay, so when we're looking at this, Evan was on a biking trail. A map of the trail is shown. His brother timed his ride from point A to point B. So what do these blue lines represent? Because that's not the trail that he took. What are the blue lines?
Legs.
The legs of a right triangle. I agree with that. What else are they? We talked about it.
A and B.
Yes, they are A and B in the formula.
Right triangle.
They're the horizontal change that he took and then the vertical change. So they're the horizontal and vertical change that he took on his trip, right?
Yep.
What does the red line represent, though? The hypotenuse,
Distance traveled.
which is also C in our formula, and then the distance that he actually traveled, right?
Yep.
Okay, so what type of triangle is that?
Right.
It's a right triangle. And how did we say yesterday that we could figure out the length of AC and BC without counting the number of units?
Subtract the X for A and C, and then for B and C, you can subtract the Y.
So we can subtract the X's, so like these ones, right?
Yeah.
And then we could subtract the Y's, which would be this and this one, to figure out the vertical change, right?
Yep.
So this would be our horizontal, and this would be our vertical. Question? Okay, because we kind of talked about that change before. So then we found out that the length of AC was
4.
4, because we took 7 minus 3. And then we figured out BC was
5.5.
because we took 9 and 5/10 minus 4.
Yes. Yep.
So then if we were writing a Pythagorean theorem, what would we use to figure out the formula of C?
First of all, you would do the good old square.
Equals C squared. So that's our equation, right? Because those are the legs. And then we would do the squares of both of them and solve for C, correct?
C 6.8.
6.8 is what we got yesterday. Okay. So questions on this. I know I kind of went through it quickly, but we kind of talked about it yesterday too.
Yeah, right.
For those who weren't here.
I'm out.
All right. So if you turn the page, I told you yesterday that we were going to use the Pythagorean theorem, and then we were also going to figure out another formula, I guess, that we could use to solve the distance between ordered pairs. When we're talking about an ordered pair, which is my x and which is my y? So like if I'm writing an ordered pair, which is your x, which is your y?
The first one.
The first is your what? And then the second one is your y. And your x's you move which way? Horizontally, so left to right. And then your y's you change up and down vertically, so that would be up and down, right? Okay. Questions about coordinate points? Okay. So in this first one, it says graph the ordered pairs 3, 0, and 7, -5, then find the distance. So the first thing we have to do is graph them. Yes, they're already graphed for you. So this is my x, so I'd go right 3, and since I'm not going up or down, I just point it. Then my second point is 7, -5, so I would go right 7, down 5, put a point, and then you connect your points. Yesterday we talked about making it into a right triangle, so I could go down and then over. That makes a right triangle, right? What's the other way that I could do it? I could go right and then down. Either way, I will get the same answer, because how many do you have to go over from here to here? 1, 2, 3. So that is 4, and then what's this? 5. We can count the squares, right? Questions on that? So what would be my formula to figure out that red line that I have? A squared plus B squared equals C squared. So what is A? 4 squared plus, what is 5? or b, 5 squared, equals c squared. What would I do first to solve? I square up exponents. So 4 squared is? 5 squared is? Then I would, what do you get? And then what do I do to get c by itself? I square root of both sides, so c is about what? 6.4, and since it's a distance, we always know it's going to be positive. Questions on those steps? Again, if you're here yesterday, this should be a review. We did take notes yesterday in our notebook, so if you missed it, make sure you get those. Okay, the guided notes are in the Monday folder in the back that you guys can get and then paste them in page 40 and 41. Okay, so this is the finding the distance using the Pythagorean theorem. We can actually find the distance formula by using the Pythagorean theorem. So, what did we say previously? How do you find the horizontal change? What did we do like just a minute ago on that previous page to find the horizontal? Without counting. The horizontal.
Oh, subtract the x's.
Subtract the x's, right? So if we subtract our x's, let's call this point 1 and this point 2. So this would technically be x, what? 1, and this would be y1. It's still the same point. So this one would be x2, and this would be y2. Okay, so if I was going to say we're just formulating a formula to figure out the change in horizontal, so in other words, this point right here, we could subtract our x's, right?
Yeah.
Okay, so that would be like x2 minus x1, correct? And that would maybe give me, we said that this was a, right? A right here. So what do we have to do to a?
Subtract 7.
What else is with a?
Oh,
The square. So we would have to square that, right?
yeah.
Because this is technically a. Plus, I would have to, how do you figure out the vertical change? So from, what did we do here? We subtract our y's. So that would be like y2 minus y1. And then what do we have to do with that? We have to square that too. So this is essentially a squared plus b squared. Because did we not figure out the horizontal change and the vertical change? Correct?
Yeah.
Okay. So that should give me, we've been calling it c squared, right?
Yep.
Well, since we're talking about distance, let's change it to d for distance. Okay? How would I get d by itself?
It already is. Wait, hold on.
It's d squared right now, so how do I get it by itself?
Square root.
Okay, so then I would take the square root of it, so I'd have to take the square root of that side. So then I would get d equals the square root of x2 minus x1 quantity squared plus y2 minus y1 quantity squared.
That seems like a super complex formula.
This is called the distance formula. It is derived from the Pythagorean theorem. So no, you're not going to be able to have to tell me the distance formula. I will give you the distance formula, but I do want you to see that it looks really complex. If I would have just thrown that at you, you probably would have been confused and like, I don't know, I'm not doing that, right? So there is a reason for it. There is a way to get it, okay? Questions about this so far?
No.
Okay. So if I wanted to solve the same problem and double check that I get the same answer, what would I substitute in for x2? So going back up here to this problem, what is x2? 7. Minus, what's x1? 3. Quantity squared. Plus, what's y2? Negative 5. Minus, what's y1?
0.
Quantity squared. So what would I do first to solve that? What? Parentheses, PEMDAS, right?
Yeah.
So 7 minus 3 is So I have 4 quantity squared plus 5 minus 0, or negative 5 minus 0. So negative 5 quantity squared. Now what would I do? Square root what?
Wait, hold up. You gotta square it.
We gotta figure out in the inside what we're gonna square root first, right?
Or negative 5.
So 4 squared would be
16.
plus negative 5 squared would be,
25.
and then that is all square rooted. So then what would I do?
Add them.
Add 16 and 25, which gives us 41. So then we would take the square root of 41, which equals what we did in the beginning. It is very long, but sometimes you're not given a graph, so you kind of have to use it. Okay? All right. We are going to paste some guided notes.